All right, hello. Today's lesson on arrays is going to be talking about how they're stored in memory, which is kind of a weird goal, but it actually affects how we write our programs. So that's going to be the goal. And I'm going to start with a review of there's two types of variables in Java, primitives and objects. All right, and so how they're dealt with in memory is actually very different. It has some pretty significant implications for how we program. So your first job here is to try and sort. Here's a bunch of variable types, 6 variable types, sort them into primitive or objects. Pause the video and give it a shot. Okay, so objects have uppercase letter. That's one way to tell objects. But there's actually a trick here where arrays, even if you have primitives in your array, all arrays are considered objects. So even though this int starts with a lowercase letter, because it's an array, it is an object. And then these other ones are just basic, very primitive, very simple. Remember, that's what primitive means, is simple. So these are simple types. Okay, so next up would be to pause the video and see if you can remember some differences between these two. So see what you remember. You don't have to write them out necessarily, but just think through what are some of the differences. Besides, objects usually have uppercase letters. Okay, so these ones are simple versus objects are usually more complex variables, complex pieces of data. Um, these are just like a bucket in memory, which is going to be is significant. That's kind of our lesson today. And these ones point to a spot in memory. So when you make a variable, it actually points to a specific spot in memory called a pointer, like a memory pointer, right? And then the other big difference is here you have to create using the new keyword. And that basically assigns new space in memory when you type the new keyword. So when you create them, so like scanner, if you remember, when we create scanner, it looks like this. You do scanner, scan equals new scanner, right? So you use that new keyword when you create an object or reference type variable, which you don't have to do when you do a primitive. Okay, so I'm going to do a visualizer here in a second, but I just want to talk a little bit about like what they look like in memory. So when you type int x equals 7, right? What that's going to do in memory is just make a little bucket and label it with x, that's the name of it, and put a value like 7 in it. All right. And then when you do a second line like int y, and if you set that equal to x, what that'll actually do is that'll make a new variable called y, and it'll give the same value as x. Sorry, the colors got all wonky there. I guess I'm not sure why I did all those colors, but basically they're two separate spots in memory. So if I change one of them, like if I change x to 5, right, that'll wipe out this and make it 5, but it won't do anything to y. Okay, and this is not going to be true in arrays. If you do this similar code for arrays, it'll actually change both of these, which is really strange, but it has to do with it being pointing. Okay, so to help us understand this, I'm going to do these Java visualizer things that I kind of like a lot. So here's one real similar to what I was just talking about, where I have main, I create an x variable, set it to 7, y initially gets set to be whatever x is at this point in the code, and then I'm going to change x to 10, right? And then print out y. So you can kind of guess here, what do you think y is going to be at the end of this code? Okay, so here we go to find out. So I'm going to run it, and we're going to watch it in memory here. So I got a bucket called x has a value of 7. The y bucket starts off with whatever x was. And then this line, x equals 10, just changes the x bucket so that y is still 7 at the end. Kind of like what you'd expect. This is what I would say is sort of normal and what I would expect. Y got set to initial value of 7, and then it doesn't change after that. So it just prints out y of 7. Okay, so now I'm going to do almost the same code, except I'm going to make these arrays or reference types. Okay, so basically I'm going to make an array x that has these numbers 5, 10, 12, 20, 32. Then I'm going to make an array y and it's going to be set to the same thing as the array X. Okay, and now I'm going to change the value at position 0. This is going to now become a 3. All right, and then I'm going to print out array Y, its position at 0. Okay, and so you would guess that at this point, probably you would guess that Y of 0 would still be 5, right? Because right here, Y is this set of values, and then we never change the Y array after that, so it should look exactly like this. But I'm going to run it, and this will hopefully make sense as I run it here. Okay, because that's not what happens actually. So on that first line, we make an array called X. And then what happens with a pointer, right? So X is pointing to this array in memory. So once we say Y is equal to X, Y is going to point to the exact same spot in memory. All right, and so that when I change X of 3, I'm really changing it for both. Sorry, if I'm changing position 0 for the X array, I'm really changing it for both. So as I move forward here, that changes both arrays. And so when I print out Y of 0, that'll actually print out a 3. Okay, so that's pretty weird, but this line is basically saying they're going to point to the same spot in memory. If I make array Y equal to array X, then it's going to point to the same spot. Okay, and if I didn't want that to happen, I would have to make, use the new keyword here, or probably just have to, retype it out. I could do something like this. I think that'd be the only way to fix this, would be to go like that. I don't think there'd be a way to force it to make a new one other than doing it like that. I mean, you could type new int of 5 for sure, but then it would have all zeros in it. Right? So anyways, yeah, that's a tricky situation. Okay, so I came up with a bunch of questions to test your knowledge of this. So I'm going to have you pause the video and try each one of these before unpausing to watch the answer. I do play Kahoot in class, but since this is a video, I'm just going to have you do it by pausing the video and trying each question. Okay, so we have an array scores. I'm going to label the indexes. Okay, and so again, when you do this line here, values is going to point to the exact same spot as scores. Right, so if I make position 3 in the scores thing, if that changes to 10, right, that's going to be the exact same thing for values, because values is pointing to the same array. So this is just going to print out a 10 right there. Okay, so this is hard to see, but what is the value of B array position 2 after this code executes? So if you can't see this, here's the values of A, and then it says A is equal to B, and then it says B is equal to A. Right, so this is kind of goofy. Okay, so what's going to happen is A is going to point to the array initial values 0, 1, 2, 3, and 4. Okay, and then B, after this line right here, the second line is going to be pointing to a different array, which has values 0, 1, 4, and 9. Okay, and then when we do A equals B, right, basically A is now going to point to array B. So this is now gone essentially, right? And then when we do B equals A, well, A is already pointing here. So this line really doesn't do anything because they're already pointing to the same spot. So B will continue to point where A is already pointing, right? And so now if I do B of 2 or A of 2, they're really pointing to the same thing. So B of 2 at this point would be 0, 1, 2. That would be the 4. This is going to print out a 4. Sorry if that one was hard to see. The rest should be okay. Okay, so what do you think is going to be printed out here? This is primitive this time, not reference type. Okay, so I'm going to go line by line, much like the visualizer does. So this is going to make a bucket with 7 in it. Then it's going to make another bucket called Y, and it's going to be initially be the value of x, not actually the same location, but just the value of 7, so that when I go plus plus y, that only increases the y to 8. So x at this point is still 7, right? Because x did not change from its initial value of 7, so this just prints out 7. Okay, next one is a method, and we talked a little bit about this before. So I'm going to make an array with numbers. Then I'm going to pass that into the increase pay method, which is void. Just loops through them all, right? And now I'm going to let you, I'm going to stop talking. You're going to figure it out, and then you can unpause to see the answer. Okay, so the method is looping through this array called numbers, and it's going to increase it by 1 each time, right? And then nothing gets returned. But what actually happens is this numbers, when you pass it in, is going to point to the exact same spot as pays. Because it's a pointer type, it points to the same spot, right? So it'll actually just increase all of these by 1, right? So it increases all the pays by $1, and you don't need to return anything to main here. It's just going to change them all. And since they're really pointing to the same array, right? Numbers is pointing to this array, so is pays. So that when you change numbers down here, increase by 1, that'll increase pays also. So pays position 0 will now be 850. Right? There's only one array here. They're pointing to the same spot, and it will now have those values. Okay, last one for you to try is like this, except with primitives. No, it's not. Never mind. It's got arrays in it. Oh, it's got all sorts of craziness. All right, so I guess you're going to have to map it out. Good luck. Okay, so I'm going to attempt to draw like this would look like in memory, like it does in the visualizer. Okay, give me a moment. Okay, so pays is going to equal to this array. And then when I do array money equals pays, money is going to point to the exact same spot in memory. Okay, so now I'm going to call it increase pays, and it really doesn't matter which one I pass in because they're really pointing to the same spot. Okay, so when the method runs, you're going to have another array called numbers, but that variable also points to the same spot. We passed in pays right here, so this numbers will point to the pays one, and it'll increase them all by 1. So after the method runs, these will all be up by 1. Okay, and then once the method runs, this numbers reference is no longer there, because this disappears after the method is over. So now it goes pays position 2. So if I label these, we'd have positions 0, 1, and 2. So I'm going to do plus plus to position 2. So that 1150 will now become 1250. All right, we increase that spot by 1. And then we say pays equals money, which it already does. So this line really is nonsensical because they're already still pointing to the same spot. So they will continue to point to the same spot. And then I'm going to print out money position 2, which is this array, same array, and that's just going to be 1250 at this point. By the end of the code, it's going to have the value 1250. Okay, so again, the whole point of this is to say primitives are treated differently than reference types. And arrays are reference types. So when you set them equal to each other, it really points them at the same spot. So the same set of data, which isn't true when you do primitives, right? They'll have their own bucket, their own set of data, right? Like in a primitive, when you set them equal, they do not point to the same spot. They have their own separate bucket. This just says y initially will take on the value of x. It's not equal to the same spot in memory. It's just equal to the value of x initially. That's what that line's saying right there. Okay, that's it. Thank you for watching. And it does matter how you program, right? Because, like if you want to change something in main that's a primitive, you have to return it. If you want to change something in a method that's an array or reference type, you don't have to return it. You can just change it in the method and it'll automatically update in main. All right, that's it. Have a good day.